I have a very simple video here. We have an auxiliary cable split up onto split up and set as inputs for this Arduino board, and these are all set up for analog inputs, and the program for reading those inputs is just stupid easy. It's so simple. We basically print the red analog values, and this is just a delay for how often it'll do that. Uploading the script. Okay, we seem to be getting a lot of noise. That's to be expected with anything analog. But let's see what happens when we play music. Okay, yep, that started playing. I just realized I don't know which of these values is what. Okay, that's a flaw. I'm gonna go fix that real quick. I've made a slight adjustment to the code. You can see here, right before it prints the red analog value, I have this thing that says which analog value it's reading. And yep, we get numbers. Oh, you know what might be useful? Let me see. Plotter. Is this dead? Okay, the volume is set to max. And so we can see that these values are pretty high, ranging from like 200 to a couple hundred. I'm now going to pause the music. These look exactly the same. Okay, no problem. I can wire up something as a output for this auxiliary cable, and maybe that'll fix this. Okay, I'm back. I did the thing. I wired it up to the opposite end of this auxiliary cable that I cut, and I have that as input for these headphones. And if you listen, I may have to boost the audio here. There's audio output from the MP3 player. So now we can be sure that these values are what's actually being played on the headphones. Now let me see if I can... Oh, something got disconnected. Yeah, something got disconnected. I'll be right back. I am back. It was easier to wire up the second half outside the breadboard than it was inside the breadboard. But here we go. We've got Joji here, auxiliary input, confirmed. And so these values are what's actually playing from the headphones. So, I've decoded some of this. Red is power, blue is right, and white is left. A1 and A2 are the left-right values. Oh, my computer went to sleep. Okay, I'm now going to pause to see what happens. Okay. It looks like it went to all the way to 0. Oh yeah. Oh, wait a minute. It's doing a sine wave. Goes down to 0. Then it goes all the way back up to 1023. That's interesting. Now I'm gonna unpause the music. Yeah, I did not think it'd do that. Huh, yeah, that's actually a sine wave. Now wait a minute. I've unpaused the music, but it's still doing the sine wave. Oh, maybe it's got something to do with the delay. That makes things a whole less readable though. I try to plot this. Yeah, nothing again, okay. I'll try delay of 100. Yeah, that's interesting. It's still doing the sine wave. Yeah, because we have the auxiliary cable input coming into here to the Arduino board, as well as coming across and going to the headphones. So this is what's going into the headphones, and it's a sine wave. Or is it? I'm gonna do a thing. I'll be right back. Yep, no matter what I do, and tried averaging all three inputs, but no matter what I do, it always comes back to sine wave. The delay just changes how quickly the sine wave moves. So if I change this to a delay of 50, we can see that the sine wave just moves twice as fast, regardless of the music. Like, I can pause this, sine wave doesn't move. I can unplug this, sine wave doesn't move. I mean, doesn't change. I can take this, unplug it, sine wave changed a little bit. To sort of show you what I was kind of expecting, I have here a integrated circuit with a photoresistor. To read inputs from that, it's just analog value, print analog value. And you can see that you get normal looking data, kind of. So if I cover this up completely, it has a high value on average. And when I let go, the values drop. Here we've got the numbers. So idle in this brightness, it reads at about 500. If I cover up the sensor, it goes up into the 700s. And if I illuminate the sensor with something, or I guess point it towards more light, the values decrease. So it's pointed towards more light, the values decrease, and I put it into shade and the values increase. So even though it's analog data, I can still understand what's going on. But with the auxiliary input, I don't know. I expected it to be sort of like this, where it was going to be increasing or decreasing depending on the music. And if I pause the music, I expected all the values to either go up and stay up, or just go down and stay down. But that sine wave that kept coming back, it's got to be some sort of interference. And maybe my hunch was correct, and that I would need to make myself a small circuit to calibrate the analog data. But yeah, oh well, this video is kind of lame.